Welcome back to my AP Calculus class. I will keep solving practice exercise problem for definite integration from number 18. Let's go. Number 18, integral 0 to pi over 6 cosine theta over 1 plus 2 sine theta. It's a u substitution. It is u substitution. Which part is going to be u? 1 plus 2 sine theta. That part is u. And then I change this equation, integral cosine theta over u, because I let the denominator part gonna be u, and then change d theta to du. How to do that? So 1 over derivative of u part du. Derivative of u part. Okay, derivative of 1 is 0, and derivative of sine theta is cosine theta. So derivative of u part is 2 cosine theta, right? Times du. Then I change these two numbers, 0 and pi over 6, lower limit and upper limit. I'll change those two numbers to u values. If theta is 0, plug in 0 for theta, you're going to be 1, because sine 0 is 1. Sine 0 is 0. And what pi over 6? If theta is pi over 6, 1 plus 2 times sine pi over 6, which is 1 half. That is 2. So 1, 2, 2. And then cosine theta cancel out. So 1 half coefficient comes different from integral from 1 to 2. 1 over u du. So integral 1 over u is ln absolute value of u, right? So 1 half times ln absolute value of u from 1 to 2. So ln 2, 1 half ln 2 minus 1 half ln 1. ln 1 is 0, so 1 half times ln 2 is the answer. That means ln 2 to the 1 half powers, because this number can go to exponent place, right? By the exponential rules, logarithm rules. So that is ln square root of 2. So final answer in the choices, in the E is the answer. Number 19. Number 19, integral from square root of 2 to u over u squared minus 1 du. It is a u substitution, but this equation already includes small u, so I'm going to let just large u equals small u squared minus 1. And then I change that small u function to large u function. Integral small u over large u 1 over derivative of u part, which is 2u d large u. Then the small u cancel out. And I can change these two numbers. If small u is square root 2, square minus 1, that's 1. So lower limit is 1. Upper limit, if small u is 2 squared is 4, 4 minus 1 is 3. So 1, 2, 3. 1, 2, 3. So there's 1 half integral 1 to 3, 1 over u du. I just told you integral 1 over is ln u, so 1 half ln absolute value from 1 to 3. Plug in 3 first. 1 half ln 3 minus 1 half ln 1. ln 1 is 0. So 1 half ln 3. So what about 1 half? 1 half can go back to exponential place over there, right? So ln 3 to the 1 half powers. So ln square root of 3. So A is the answer. Let's go number 20. Another u substitution problems. Which part gonna be used? Yep. U squared minus 1, that part gonna be large u. So I'm gonna change this. Integral u over large u squared times 1 over u part derivative, which is 2 small u. It's very confusing, large and small. Let's cross out first anyway. And then the large u, and then change two numbers, right? If small is root 2, that's 1. What about small is 2? That's 3, right? So 1, 2, 3. 1, 2, 3. integral 1 to 3. So 1/2 integral 1 to 3, 1 over u squared left. That means u to the negative second power. And then gonna be u power 1/2 times it is a power 1 over n plus 1 times u to the n plus 1 powers. N is negative in this case. So negative 1 times u to the negative 1 powers. From 1 to 3, so negative 1/2, and then 1 over u, and then from 1 to 3, plug in 3 first. Negative 1 over 6 minus negative 1 over 2. So negative 1 over 6 plus 1/2, that is 1/3. So E is the answer. Next problem, number 21. Here is another U substitution. It keeps serving U substitution problem. A lot of U substitution problem. Which part is going to be U part in this case? This case, sine 2x. Sine 2x part is going to be U. Why? Derivative of sine 2x is 2 cosine 2x. So cosine 2x and then cosine 2x in the numerator. And the problem will be cancelled out. That's why sine 2x is U part. Keep doing that. Integral cosine 2x over sine squared 2x, so u squared. And then 1 over derivative of u part. Sine's derivative is cosine, and then chain rule by chain rule times 2. Because the 2x is inside the function, and then du, and this cosine 2x cross out. What about bottom number? If x is pi over 12, sine 2 times pi over 12, which is pi over 6, right? That's 1/2. So bottom number gonna be 1/2. Top number, upper limit, when x is pi over 4, sine 2x, sine pi over 2, which is 1. So 1/2 to 1. So 1/2, this 1/2 just a constant coefficient goes to front, and then the integral negative 1/2 to 1, the u to the negative second power again, du. So integral of u to the negative second power by power rule, that's negative 1 times u to the negative 1 over u, and then from 1/2 to 1. So negative 1 over 2, and then plug in top number, which is 1 minus plug in bottom number. So 1 over 2 is 2. So positive 1/2. Negative 1/2 times negative 1, positive 1/2. C is the answer. C is the answer. Number 22 is another U substitution problem. Integral, which part is going to be U? Oh, it's not U substitution, I'm sorry. I'm going to change this fraction, just separate this fraction into two fractions, like e to the negative x over e to the negative x plus 1 over e to the negative x dx, and then simplify that. So integral 0 to 1 plus this part e to the negative x to the negative 1 powers, e to the x powers. And then find that indefinite integration first is what is the integral of x part is 1, integral of 1 is x, and integral of e to the x is e to the x. From 0 to 1, plug in top number 1 plus e minus bottom number 0 plus e to the 0 powers. So that is just e, because 1 and 1 cancel out. E, A is the answer. Number 23. This is U substitution. So on the bottom part, e to the x plus 1, that part is going to be u part. So this equation is going to be changed 0 to, not 0 to, I'm not going to write down now. I'll change numbers later. E to the x over the whole thing's bottom part is u, and then 1 over derivative of u part, which is e to the x, and du. And then that e to the x, e to the cross out. And then I'm going to change two numbers. If x is 0, u is 2. If x is 1, u is e plus 1. E plus 1. So integral 2 to e plus 1, and then 1 over u du. Integral of 1 over u is ln. ln absolute value of u, and then from 2 to e plus 1. Plug in top number ln e plus 1 minus ln 2. So we can combine those two, right? So ln e plus 1 minus ln 2, you can ln e plus 1 over 2. Okay, by properties of logarithms. What is property? Log base ax minus log base ay is equal to log same base a x over y by this property. Okay, the answer form going to be changed like that. What's the answer? E is the answer. E is the answer. Okay, I have one more problem, say number 24. It is a little different type of U substitution problem, okay? It is different. So x is given, x equals tangent theta, and then just plug in tangent theta for this x. Okay, so integral, I'm gonna change the number for bottom number, top number first. If x is 1, what is theta? 1 equal tangent theta, right? Tangent what degree is 1? 45 degree, right? Which is pi over 4. So if x is 1, theta is pi over 4. If x is root 3, tangent 60 degree root 3. So what is the radian angle for 60 degree? Is pi over 3. So pi over 3 is upper limit. And then change that function to theta function. So 1 plus x squared means tangent square theta. And then change dx to d theta. Use implicit differentiation. X equal tangent theta. So 1 dx is equal to secant square theta d theta, because derivative of tangent theta is secant square theta. So you change that, secant square theta d theta. You're almost there. By Pythagorean identities, okay, 1 plus tangent square theta is what? That part is going to be secant square theta, right? Square root secant square theta, that's a secant theta, so that is integral pi over 4 to pi over 3 secant theta times secant squared theta, so secant cubed. Secant theta's cube, right? D theta. You don't have to calculate it, just find that expression. Where is that expression? That's a C. C exactly says the same expression. So C is the answer. So I solved just from number 17 to number 24. In the next video, I keep solving from 25. Okay, thank you so much for watching my video. Please click subscribe and like, and turn on the notification. Thank you. Bye-bye.